Welcome! In this CBSE and NIOS aligned lesson, we will learn the coordinate, also called dative covalent bond, ligands, and coordination number. We will build intuition with clear pictures and step-by-step examples. Definition: in a normal covalent bond, each atom contributes one electron to the shared pair. In a coordinate covalent bond, both electrons of the bond come from the same donor atom. We use an arrow from the donor to the acceptor to show the direction of electron donation. Conditions for formation. 1. The donor atom must have a lone pair of electrons. Typical donors are nitrogen, oxygen, or sulfur. 2. The acceptor atom must have an empty orbital to receive that pair, often a metal ion or an electron-deficient atom like boron. Example 1. Ammonia donating to boron trifluoride. On the left, we draw ammonia with a lone pair on nitrogen. On the right, boron trifluoride is electron deficient. Boron has only 6 electrons in bonds and an empty orbital. The lone pair on nitrogen donates to boron, shown by the arrow from nitrogen to boron, forming N to be coordinate bond. After formation, this bond behaves like an ordinary covalent bond. Example 2, the ammonium ion. Ammonia donates its lone pair to a hydrogen ion. This creates N to H coordinate bond, and the result is the ammonium ion. Importantly, in ammonium, all 4 N to H bonds become equivalent in length and strength. Example 3, the complex ion iron, CN6-3-. The cyanide ligands each donate a lone pair to the central iron 3+. 6 coordinate bonds form, giving coordination number 6, and an octahedral arrangement in 3 dimensions. Next, ligands and coordination number. A ligand is any ion or molecule that donates one or more electron pairs to a central metal. Types of ligands. Monodentate donates 1 pair, for example, ammonia, water, chloride, cyanide. Bidentate donates 2 pairs, for example, ethylenediamine or oxalate. Polydentate, also called chelating, donates many pairs, for example, EDTA, giving highly stable chelates. Coordination number is the total number of donor to metal bonds. To find it, count each donor atom that binds to the metal and add them up. For example, in chromium, N2 chloride 2+, each N is bidentate, giving 2 donors each. 2 N ligands contribute 4, and 2 chloride ligands contribute 2 more. The coordination number is 6. Common coordination numbers and geometries. 2 gives linear, for can be tetrahedral or square planar. 6 is typically octahedral. Key points for CBSE and NIOS exams. Always draw the donor lone pair. Use an arrow from donor to acceptor for coordinate bonds. Provide 2 classic examples, ammonia donating to boron trifluoride, and formation of ammonium. State that after formation, coordinate bonds become indistinguishable from ordinary covalent bonds. For coordination number, count donor to metal bonds and recall typical geometries. Summary: a coordinate covalent bond is made when one atom donates both electrons of a bond to an acceptor with an empty orbital. This is the Lewis acid-base idea. Ligands are donors, coordination number counts donor to metal bonds, and common geometries follow the coordination number. With these tools, you can confidently analyze complexes and bond types.